Welcome to qnawire.
In this problem, going back to problem, let's see here, problem 16, and we have a source temperature of 1500 Kelvin and a sink temperature, or basically a sink temperature or a low temperature of 290 Kelvin. So we can across the pump here, we have a saturated liquid at 10 kilopascals. So we can look up the entropy for that. And then we have the entropy across the turbine, and we looked that up already. And we go back to the problem, and we see that basically on the inlet and the exit of the turbine, we have the same entropy because it's isentropic. Again, we calculated the heat transfer in, the specific heat transfer in, and the specific heat transfer out in the problem, on problem 16. So because the pump and the turbine are isentropic, we have no exergy destruction because they also have no heat transfer too. So basically these things are the same and these are the same. So we have no exergy destruction there because they're adiabatic and isentropic. Now for the boiler here, we have the change in internal energy and then the entropy from the heat transfer multiplied by the surrounding temperature, and that winds up being 1,112 kilojoules per kilogram. In the condenser, again, the change in internal energy of the fluid, and then the entropy created from the entropy generation from the entropy change from the heat transfer over the low temperature. And we wind up plugging all those numbers in, we wind up with 172.3 kilojoules per kilogram.